Our next presenter is from CARR Biosystems. Joining us is Josh Adams, Bioprocess Leader. Josh's presentation explores scalable, automated separation technologies designed to support consistent, high-quality downstream operations across modern biologics and advanced modalities. He's going to demonstrate how unifuge single-use centrifugation systems improve recovery, repeatability, and process efficiency. Welcome, Josh.
Yeah, thank you, Perry, for the introduction. And thanks everyone for joining today. I'm excited to be here. We'll switch that. Thank you. Over the next few minutes, though, we'll look at some how to select the right cell separation technologies and how to make scaling smoother, ideally getting it right the first time. So first, I want to start off with a little bit of background about who we are. CARR Biosystems is a part of the Berry-Way-Miller family of companies. We've been focused on the centrifugal separations technologies for over 30 years. We design and build everything here in our Clearwater, Florida facility, supporting customers around the world with our global team. Our systems play critical roles in many FDA and globally licensed biomanufacturing processes. And with this history, we support a wide range of modalities across the industry. You'll see our systems used in cell therapy for a variety of cell types, in gene therapy, vaccine manufacturing, biologics, and even areas like cell agriculture. Diving a level deeper from modalities into applications, our Unifuge platform fits into multiple steps across the cell processing workflow. So today, we'll dive deeper into a typical biologics workflow and how CARR Biosystems can support cell banking, seed train expansion, media exchange, including perfusion intensified processes, and of course, harvest clarification, which is part of our focus today. And since this session leans more downstream, I'll highlight a couple of clarification case studies, and we'll talk through how to think about scale up early on. All right, so when selecting equipment for downstream processing, teams often start with what's easy or already within their lab. As a process matures, the priorities start to shift. The focus becomes more on unit operation yield, repeatability, and controls. And then eventually, as you move toward clinical and commercial production, manufacturing readiness and tech transfer become critical. At these later stages, we frequently hear from teams who feel locked in to a technology that doesn't scale very well later. And this creates delays and expensive process changes. So here you can see that thinking about your CMC strategy, defining your critical process parameters early and how they influence your critical quality attributes, and your long-term tech transfer implications, it can save a lot of time instead of addressing that later when the momentum is much harder to shift. Okay, so considering options for a system that supports a robust CMC strategy, I want to introduce the Unifuge system. Each system includes standard equipment, which comes in a variety of sizes, with a consistent interface and simple scalable controls. We have a single-use sterile module. This consists of the single-use bowl with the tube set attached for aseptic integration into your workflow. And then all this includes automated recipes for consistency and traceability. With this combination, you have closed and consistent and GMP compliant separation steps from the beginning. All right, so with the sizes, we have three systems that we offer. The Unifuge or the UF Mini can process as little as 100 milliliters to tens of liters in a batch. The UF Mini scales to our UF Pilot, enabling processing of volumes from tens to hundreds of liters, depending on process demands. And then ultimately, the U2K provides scale-up capability to process into the thousands of liters with ease and speed. And if you start with the UF Mini, it naturally scales between those other systems. Now that we're familiar with that lineup, we'll take a moment to highlight these real world examples, thank you, of the equipment and how they're used across different applications. So this first case study I'll go over is an HEK cell harvest with a C-train intensification workflow. For this study, we were looking for an efficient harvest of HEK-derived cells in a biologics production type workflow. So the ultimate purpose was to improve scalability and reduce the workflow bottlenecks. The process goals were to capture the cells more efficiently. For this presentation, we'll focus on the supernatant turbidity and how it compares to different flow rates. First off, we'll note that we recovered greater than 95% of the cells with excellent viability. And then we also saw a high turbidity reduction from approximately 200 NTU down to around 2 NTU. And this reduction rate was consistent across multiple flow rates. And I'll present some more data later that show this is consistent with our other sizes of unifuge as well. Okay, so in another study, we evaluated how tubular bowl centrifugation performs in biologics clarification. This was harvesting a CHO cell culture. Here we compared a unifuge-based primary clarification step against traditional depth filtration as the primary clarifier. The result, based on secondary filter back pressure and filter loading, we captured more filter clogging debris than the depth filter, showing that we are able to replace the primary depth filter, with a unifuge, and thus reducing overall filter consumption by 50% or more. And then you can see the UF Mini and UF Pilot perform similarly, showing that both are suitable as you scale up or down across your PD and GMP runs. And again, you can find the full publication for this in the BioExpo portal or this QR or with the QR code. And ultimately, a large takeaway from this talk is about tech transfer and scale up. As you progress from R&D to PD and ultimately to clinical and commercial manufacturing, the scale of your operations will change. So the question is, how do we choose technologies that enable that next step in a product development journey? There we go. Okay. For easy scale up and scale down, the Unifuge family is designed for scale. The tubular bowls, as shown here, are engineered with scaled geometries, and we've kept things simple with using only 2 critical process parameters for separation. So we have flow rate and the relative centrifugal force, or G-force. We have proven scaled performance across systems using a sigma factor and flow. The sigma factor being a function of the bowl speed, the bowl speed, the RCF, and the bowl geometries. And then here is our sigma factor equation for scaling. So if you divide the flow rate of one centrifuge by its sigma factor, we can predict the flow rate of a scaled unit based on this ratio. So with this sigma factor equation, we have the tools to define the relationship between the process parameters and the micro, mini, and so on. And this method has been proven to effectively scale processes between different equipment sizes in the Unifuge family. And I'll show a plot. Oh, here we go. Next, but yeah, based on your process steps and goals, our team can help determine whether scaling out or scaling up is the best fit for you. Unifuge systems support both approaches really well, depending on your batch size targets and processing time requirements or your operational strategy. So for scale out approaches, this is ideal when you need to run multiple batches in parallel or adjust to variable batch sizes common in early development or when flexibility is key. So each Unifuge system uses simple automated recipes that can be duplicated across units. So running devices side by side is essentially a recipe copying operation. For a scaling up approach, when your goal is to move into larger batch volumes or to streamline operation, we have proven comparability between the Unifuge product line So this is the plot that I was talking about that shows the turbidity reduction achieved from several different machines and different flow rates. The trend line shows linearly predicted performance using the flow over sigma scale-up approach. So with this relationship staying the same, your team doesn't have to rework solutions during engineering runs or tech transfer. So you can get it right first time. There we go. To summarize, the Unifuge family is engineered to support your CMC strategy independent of where you are in the drug life cycle, as it is repeatable across scales, has consistent critical process parameters that translate into consistent critical quality attributes. And that can be defined earlier in your process, in your development, making it easier than ever to lock down the crucial parts of a process and tech transfer with confidence. So the Unifuge family is flexible, independent of modalities, and it's scalable from milliliters to thousands of liters, repeatable from batch to batch, and predictable based on the automation. Ultimately, confident tech transfer starts with robust, predictable process development, which is what the Unifuge enables. And yep, if you're exploring a new process or scaling an existing one, our team can support. We host Unifuge demonstrations at your site to simplify the evaluation process and can help your team quickly understand how the system performs in your process. So these demos can focus on here like proof of concept runs, process optimization, scale up, and tech transfer guidance. So feel free to reach out through our website or email to schedule an application consult or an on-site demo. Thank you. Yeah, we can move on to questions.
Thank you, Josh. Great solution. Really interesting stuff. What are the most common applications that you have case studies for that you could share with us?
Yeah. So beyond the MAB applications we discussed, we see a lot of success with those working on cell therapies like MSCs, iPSCs, and T cells, NKs, everything. So it can be used in that application for harvest, for washing the cells, concentration, or similarly like buffer exchange, media exchange steps. So we have application notes on all of this. And then additionally, there have been people working on it with for like viral vector harvest, and many other interesting and kind of fringe things as well. But yeah, this is a very cross-functional. They're very broad.
Yeah, very good. Can you clear solids from the bowl and increase the centrifuge capacity?
You can. So this is designed to be able to cycle and clear those solids. And so that's one of the other things that our teams can work with on is just how to really efficiently and effectively get those solids cleared out, whether you're interested in the solids and you need to keep them safe, or whether that's part of the waste stream. We can work to do that effectively.
Drug innovators often have, very diverse pipelines. They have a lot of different multiple production platforms. How versatile is the Unifuge system?
Yeah, as kind of mentioned, that's one of the great benefits of the Unifuge. The equipment can support different cell lines and workflows without any hardware changes. The users can adjust the recipe parameters and save those recipes for specific applications. You can name them with that application in mind and switch to it. And again, you have the single-use inserts that can be swapped out within a matter of minutes if needed.
You spoke about scaling up, scaling out, always important considerations, but scaling down doesn't often come up, but you mentioned it. But it is done for process optimization work. So is the Unifuge system equally adaptable for that?
It is, yeah, and we'll use that scale down model to do scaling down as well. So again, if you're looking for process optimization, we do have case studies that can highlight these uses, but it's definitely a great option for trying to optimize by scaling down.
And the examples that you spoke about, are these continuous centrifugation methods?
So it is a continuous outflow of the supernatant. So we continuously feed in, the solids are collected inside the device, and the supernatant is continuously expelled or sent on. So, and then the solids retrieval would be intermittent.
Okay. So I take your system on. What kind of support are you going to give me?
Yeah, so our team, they're available for the on-site and remote support through evaluation, through early development. So basically, we'll want to provide the equipment know-how. We offer trainings, different depths of training involvement, and then application experience to help you really put your best foot forward. And so we'll make sure that you're walking or running successfully before, that's what we're there to support.
All right. Awesome stuff. Great system. The Unifuge single-use centrifugation system. Awesome stuff. Thank you. Josh Adams, he is a bioprocess leader with CARR Biosystems. Josh, thank you for being with us today.
Yeah, thank you, Perry.